Cashify. Okay, I notice we're getting a little bit. Well, I don't mean it in a bad way. I'm not complaining, but I think I and you are both getting a bit condescending or a little bit arrogant, a little bit accusatory in the motivation. And frankly, I'm fine with that. It does not cross the line for me at all. In my case, it's because you are claiming lots of skeptical values. You mentioned with derision uh, the clinging to some sort of absolute truth. And yet you propose absolute truths. That's why we're having, well, that's at least part of the reason that we're having this is a debate, okay? When I say you're too certain or you're accepting just what you want to believe, take that out of context a little because the point is I'm saying that to you as a skeptic. And you made these comments about clinging to absolute truths. And and yet I think you do. You keep saying, emphasizing what we don't know, but then going on how you do know. And plus, I think there's no way to say. I mean, I'm not saying this to be condescending, but there's no way to not sound condescending when I'm telling you that you've got this light speed time stopping thing a little bit mixed up. Okay. Now, the whole thing about, of course, light goes light speed. Listen, that's just semantics. You're being fooled very much by the framing of that. In one sense, of course, light, whatever speed it goes, is light speed. If it slows down to 50 miles an hour, that's light speed. Well, that's what happens in a medium. Okay, light slows down. All right. So that's what I was talking about, is that even in space, it's possible light is going slightly less than this light speed in a vacuum. Why? Because vacuum is this idealized idea. There is no vacuum. And we used to, we still and used to think for sure, well, there's vacuum in between. Well, no, maybe there's not even vacuum in between. Maybe space itself is made of these particles. I don't know. I don't necessarily think that. But the point is, we don't have access to something that's a vacuum. And we're looking close enough now to see that the things we thought were vacuums are not perfect vacuums if you look close enough, okay? So that was just the point about that maybe light doesn't even go this light speed, because light speed is a very different thing. It's the maximum speed of electromagnetic waves and so on. And, it's hard to know if light is going exactly that or just closer than we can tell right now. So that's me invoking doubt. But I'm invoking doubt because you are trying to draw conclusions from things that I'm doubting specifically. Okay, so it's good to be specific. Now, the this is where I think this is how I think you've got the light speed issue wrong, and I'm going to try to describe it again. There's really two cases. One is in relativity, where you grow to light speed. You're trying to get light speed. The creation of a photon is different. It spontaneously, from the moment of its creation, goes at light speed. Okay, in general relativity, if you're trying to obtain light speed, whatever your mass, it will take infinite energy. And another thing is that I'm not being condescending. This tone or attitude that I have has to do with the fact that I can tell you understand general relativity, at least, in these issues, like me, not necessarily as a physicist about to get a Nobel Prize, but, you know what I'm talking about. You know that if you are trying to obtain light speed as we would have to, or as any, baryonic matter around us would have to, it would take infinite energy. Okay, it does not obviously take infinite energy for a photon to be created. It takes just the amount of energy that the photon has in it, or maybe some little tiny bit more of inefficiency. I don't know, stray energy, but pretty much a lot less than infinite. Okay, so right there, general relativity is not necessarily talking about that photon, because something different is going on with that photon. Something different than what's going on with the kind of matter we are actually primarily made of, or at least the part we're talking about accelerating to light speed, right? Because the energy in us, when it's carried from one particle to another, when a massive particle to another, does travel at light speed. But it's bound in this system, which as a whole is not traveling at light speed. So there's two differences there. Now, when you say light stops, you're using general relativity. So you're using the model of growing to light speed. This model that says you can't obtain light speed. This model that obviously doesn't even try to really apply at light speed in it, right? It's a lot about light. It relies on light. But when it talks about this light speed issue and time stopping, that's about moving mass like we're made of. But I'm willing to do that. Let's do that. Let's say that even through analogy, that in some sense, light, the time does stop. Well, you need to remember that you're using this metaphor. Use the whole metaphor. Okay, use the whole relativistic metaphor. And by that I mean, when you are accelerating to light speed, time doesn't slow for you, right? In other words, to the photon, we're the ones moving at light speed. Now, I know you want to say, well, forget about position. Wait. We're doing this by induction. So as we get faster and faster, things are happening, and we're trying to induce what's going to happen next based on what happened previously. And what happened previously was that, for me, traveling faster and faster, the Earth that I left, that's the thing that looks like it's time slowing for. If you're on Earth, it looks like time's slowing for me. So it always looks like time is slowing for the other person. The other person. So that would imply, if you're using induction from this to make your conclusions about the light, but the photon, that from the photon's point of view, time on Earth has stopped. Time everywhere else besides itself has stopped. Now, you're like, but how could time continue for the photon? I don't know, but you're the one that wants to use this metaphor, so that's one of the things you have to draw. And that's why I'm saying, yeah, there's some contradictions, which is a reason not to go too far into that. Okay, and I and you as a skeptic, or with skeptical values, not to label you, but I just mean, you're talking against absolutes and things. And you seem to reflect many skeptical values, many cautious values. Well, if you're going to embrace the contradiction, then it needs to be for a reason, and it can't really be considered a certain knowledge. I believe in contradictory theories, right? Like relativity and quantum mechanics, or at least incompatibilities like particle and wave duality. I believe those, but I know that those contradictions are evidence that I've got something mixed up a little bit. Those aren't contradictions in the end. There's some sort of unifying principle. I don't believe we ever get rid of all the contradictions. I believe there continue to be contradictions, but I also believe we can continue to sort them out. Okay, so that's what I was trying to say when I was saying in the last video, that I would like you to think about these things, that the induction that way. I don't know what you mean about superposition and omnipresence. I don't understand. I mean, I understand superposition increases the presence, but it doesn't make it actually everywhere. It might make it an infinite number of states and phases and points, but that doesn't mean it's everywhere, because there's infinite number of points in a line segment. But there's also infinitely many non-intersecting line segments. So there's these multiple dimensions of infinity. For something to be infinite doesn't mean that it's actually everything. Okay, now, again, I mean, I think you know that. I just want you to add these up together and see if you don't get the same thing I got. So, okay, the time's running out, but I had a little more to say. Maybe I'll make a second video, or maybe not.